Okay, so let's continue talking about sets. So we were here, this is where I left off. So set A is, let's talk about what equivalent means when we're talking about sets. So set A is equivalent, okay, to set B. And the symbol right here means if and only if. Right. In other words, you can think of it as a definition, right? It means set A is equivalent to set B if and only if set A and B contain the same number of elements, okay? The same number of elements. So, for example, and again here, if you want to use an additional piece of paper, that's fine. Whoops. Okay, so I'm gonna pretend this is our piece of paper here. I'm gonna write it here. So let's say I give you a set. So set A is going to be, and I'll write it in set builder notation because this is good practice, X such that X is a vowel, and set B is going to be the set of all X, right, elements, such that X is an element of the natural numbers, and we have this inequality. Okay, so what is set A equal to? Okay, well, this is saying the collection of all X, okay, so probably all letters of the alphabet, such that X is a vowel. Well, out of all the letters in the alphabet, how many are vowels? Well, we can actually write them out, right? A, E, I, O, and U. Okay, so that's, let's do some color coding. So this is what set A looks like. And set B, let's make it in maybe green. Okay, so set B is the set of all, again, objects, elements, members, right? This is a general, the big kind of all the objects, right, or all the numbers, such that, two restrictions, right? X is a natural number, and the natural number is between 3 and 7. So if we actually write out the natural numbers, right, and here is the start, right, and here is the finish, we have 3, 4, 5, 6, and 7, right? I don't go up to 8 because it stops at 7. And so that's what my green looks like. So notice that the number of elements in the set, so the same number of elements, so A, E, I, O, U, well, that has 5 elements, and 3, 4, 5, 6, 7, right? Those are 5 elements. Thus, since the cardinality is the same, then we say that these sets, that A and B are, are equivalent, right? Not equal, because it's actually different when we talk about sets, but equivalent, right? Another way of writing, I mean, you can count, you can determine the cardinality. So here, for example, n of A is 5 and n of B is also 5. But we can set up this this one-to-one correspondence, which basically just says, let's see, if I write my set A, so A, E, I, O, and U, and my set B, which is 3, 4, 5, 6, 7. If you can actually set up a one-to-one correspondence with arrows, so A goes with 3, E goes with 4, I goes with 5, O goes with 6, and U goes with 7. I mean, they have there's a one-to-one correspondence, so we can say that these sets are equivalent. If there isn't a one-to-one correspondence, then we know it's not equivalent. And that's what this says here. So if A and B cannot be placed in a one-to-one correspondence, then A is not equivalent to set B. So I will stop here and then I'll move on to the next video. Okay, so let's talk about sets that are equal, okay, not equivalent, but equal. In mathematics, when we're talking about sets, there is a difference. So set A is equal to set B means that if A and B contain exactly the same elements, so exactly the same elements, regardless of order, or possible repetition of elements. We symbolize a equality of sets A and B by using the actual equal sign. Okay, so for example, let's say, just to change it up with some letters, so capital C is the set of, let's see, Jennifer is in this set. Jennifer Cook, let's see, Taylor is part of the set, Brittany, and how about Cassandra? Okay, so there's 4 elements in set C. Now, if I write set, I'll just keep it in red, set D, and I decide to put Taylor first, and then Cassandra, maybe Brittany, and then Jennifer. Now, are these sets equal? Is C equal to D? And the answer is yes. They are equal because they contain the same elements, right? If I say Jennifer, whoops, I get the pointer here. If I say, oh, what's going on here? Okay, there we go. If I say Jennifer, Taylor, Brittany, and Cassandra, you are in group C today. And by the way, Taylor, Cassandra, Brittany, and Jennifer, you're you're in group D. Well, I mean, C and D are really the same because it has the same people. So these sets are equal. So that's it for equal. Again, equivalent and equal do not mean the same when we're talking about sets, collections of objects.